These are the solutions to chapters 3 and 4, the final exam review. So we have to go back into our notes and look up some formulas. So for chapter 3, and I will be giving you guys a formula sheet to use on the final exam, even though you can look things up, at least everything will be in one place. So for chapter 3, what we really need to understand here, remember, is the formula for variance. I know you'll have use of your calculators, but for some of these problems, I will be asking you to show your calculations. What you could do just to check for number 1 is to use a list and spreadsheet on your calculator, but this isn't a large list of data, so I'm going to go over this, and I would expect you guys to be able to do these without using the list and spreadsheet, but this is a good way just to check. So notice at the very top of every review for the chapters here, I'm giving you sort of more focused items to concentrate on. So for number 1 here, I have a list of data, and what I want to do in order to find the median especially is I want to put this data in order, and it's also going to help with the mode, and then just going back over some other words in the formulas here because it has been quite some time since we've looked at these. So what I want to do is just put the data in order. If you notice, I have 16 data values here. Now to find the mean, all you have to do is add all of these up and then divide by the 16 that we're looking at. Now keep in mind, this is raw data, so we want to round to just one more decimal place. So the mean, or x bar, happens to be, our total is actually 771 over 16, which turns out to be about 48.2. The median would be the middle number, so we have an even amount here. So I'm going to count just 8 from the right and then 8 from the left, and it puts us right here in the middle. So we would take the average of 48 and 50, so our median is going to be 49. The mode is values that show up the most. So if you notice here, we have several values that could be the mode. We have 2 20s, we have 2 50s, and we have 2 60s. So our mode is going to be those 3 values. Remember, we could have no mode, we can have exactly one mode, or we can be multimodal. In this case, our mode is 20, 50, and 60. The range and the mid-range, be very careful here. I'm going to write out the mid-range first. That is the sum or the average of our lowest value and our largest value. So this is going to equal 20 plus 78 over 2. So we're getting 98 over 2, which is 49. That's something that the calculator wouldn't tell us. The range itself is just the difference between the greatest value and the lowest value. So the range is just going to equal 78 minus 20, which is 58. So notice the difference that's here. Going back up to the variance, and this is something you can get these values from the calculator, but if you were to make a list and spreadsheet, or you could do these simply on your own, but if you were to take each value and square it and find the sum, I'm just going to write this out, as the sum of all the x values squared is actually 41,567. As I mentioned when finding the mean, the sum of all the x values is 771. So I'm going to write out this formula here. So our variance, which is s squared, is going to be our sample size here, which is 16, times the 41,567 minus the 771 value squared, all over 16 times 15. And again, we're going to round this out to the nearest tenth as well. And you should be getting a 294.3. So this is our variance. And then our standard deviation is just the square root of this. So S, which is our standard deviation of the sample, is the square root of 294.3, or even if you kept the entire value in here, you should be getting 17.2. All right, so again, just to emphasize, we have our variance of 294.3, our standard deviation of 17.2, and we found everything else below here. The 5-number summary. To review this, the 5-number summary is the median, the first quartile, and we could absolutely use our calculator for this, but because again our data is fairly small, I'll show you again how to use just by looking at the list here. And then our third quartile, we want our lowest number, so I'll say the min, and then we want our largest number, the max. So the first quartile, now that we found the median of 49, which we already have, the first quartile is just the median of the lower half. So I have these 8 numbers for the lower half. So I want to go right in the middle here, and that's going to be Q1. And then the median of the upper half, which is going to be right in between here, that's going to be Q3. So if we find the average of 31 and 40, so I'm going to write this out here, Q1 is going to be 31 plus 40, so it's the average of that. So we're looking at 71 divided by 2. We're getting 35.5 for our first quartile. Q3, that's simple enough because they're both 60s. That's also going to be 60, what would fall in the middle. Our median, which is also known as the second quartile, that was the 49. The minimum number here is going to be 20, our smallest value, and then our max is going to be 78. So that's the 5 number summary, and then we want to construct a box plot here. So we're just going to make a number line. You guys remember doing this for 40 holes of golf activity. I'm just going to number this from 20 up to 75 perhaps. We don't have to label everything, so we can just say this is 20. We can count by tens if you want, so then we can just say this is roughly 30, 40, make this a little bit longer. Try to get them as evenly spaced as we can. All right, so looking at our smallest number that we do have as 20, just to draw this here. Our Q1 is what we're going to hit next, so about a 35.5. Safe to say it might be there. Our Q2 is 49, so we could plot that here. Q3 is going to be 60, and then we have a max at 78, so we could put this here. So we want to draw a box around the 3 middle points. And then we draw our whiskers going out, and also known as a box and whisker plot. So there is our box plot. And then if you constructed this on the calculator, you should see that it matches as well. All right, so for the inner quartile range, the IQR, remember that's just the difference between Q1 and Q3. So that is this, what was that? 60 minus 35.5, which is going to give us a 24.5. So that's our inner quartile range, and we're going to use this to test for outliers. So remember, our lower boundary is going to be Q1 minus 1.5 times the inner quartile range. So if we looked at that, that's 35.5 minus 1.5 times 24.5. That gives us a negative 1.25. We definitely don't have any values below that. The upper boundary is going to be Q3 plus 1.5 times our IQR. So then that's going to be 60 plus 1.5 times 24.5, which gives us 96.75. We don't have any values above that, so here there are no outliers. That's again how we conduct our test for outliers. All right, number 2 is having us use Chebyshev's theorem. So it says for a certain type of job, it costs a company an average of $231 to train an employee to perform the task. Standard deviation is $5. Find the minimum percentage of data values that will fall in the range of $219 to $243. So Chebyshev's theorem, remember, is 1 minus 1 over k squared. So in order to find k is the number of standard deviations. So in order to find this, we're going to take our smallest our largest value here, subtract the mean from it, because if the mean, think of the standard normal deviation, even though Chebyshev's theorem works with any type of distribution, but if we were to picture the normal distribution, that mean of 231 would be right in the middle. So we want to know how many standard deviations to the right is this 243. And technically it could work with the smaller number too, but we like to stay with the positive value. Notice we square k anyway, so it doesn't matter what it is. So we're going to take 243 minus 231 and divide it by the number of standard deviations here to figure out how many standard deviations away the 243 is. So we'll divide that by 5, and we actually get 2.4. So then we come over here to this formula, so we're going to say 1 minus 1 over 2.4 squared is 0.83. So we could say at least 83% of the data values fall between the $219 and $243. All right, so just a refresher on Chebyshev's theorem. All right, for 3, we're looking at percentiles. So we did talk about this back in this chapter. So it says the number of years served by selected past members of the U.S. Supreme Court is listed below. Find the percentile rank. Remember, it's not the same as a percentage. A percentile, just like a quartile, a percentile is dividing all of our data values into the hundreds here. So we want to know how much of the data is going to fall below this. That's going to put this person or this score, because we're comparing it to the entire group, is going to put it into this percentile. So notice all of these are already listed in order. If they're not, we want to put them in order. But the formula here to figure out the percentile, I'm just going to call P, is the number of values below X, in this case 19, plus 0.5 divided by the total number of values, and then times 100. So in this case, P is going to equal, if we look at 19, we don't include the 19, it's just the number of values below that. So there are 6 values below, plus the 0.5. We have 11 values here altogether, then times 100 should be giving us 59. So we're looking at the 59th percentile. All right, so keep in mind, these chapter reviews that I'm sort of breaking down the final exam review into are going to be your best bet to prepare. All of these questions are going to be very similar of what I'm going to give you on the final exam. All right, let's take a look at chapter 4, probability. Keeping in mind, we looked at 2 formulas for probability. When we're looking at the probability of A or B, that's looking at, like with cards, are they mutually exclusive or not mutually exclusive? Remember, mutually exclusive means if I was asking you for a 6 and a king, or a king, we cannot get a card that's a 6 and a king at the same time. If they're not mutually exclusive, means they have some overlapping and we end up counting them twice. So I just have this formula written out here that the probability of A or B is equal to the probability of A plus the probability of B minus, if they have anything in common, we have to subtract that. When we're looking at probability of A and B, this is showing that we're maybe flipping or taking 2 cards or rolling 2 dice. So it's more than one event, but are they independent or dependent of each other? And this is usually with replacement or without replacement, those types of problems. So probability of A and B is equal to probability of A times the probability of B. So to go over each answer here, notice we're looking at probability and counting rules, what I just mentioned, independent, dependent events, mutually exclusive events, permutations, and combinations at the very end as well. So for number 1, when just a single card is selected from a deck, find the probability of getting a diamond. So again, we need to go back to how many diamonds there are. There's 4 suits, so 1/4. There's 52 cards altogether in a deck. So we're looking at 1/4 or 13 out of 52. So we could say for that. For B, that we're getting a face card or a spade. So if we count, remember, face cards are only jacks, queens, and kings. So we have 3 per suit. So we have 12 face cards out of the deck, plus a spade is going to be 13, or 1/4 of it. But then we have to subtract. We already counted all the spade face cards here in this 12, so we need to subtract the 3 spades we already counted, or we're counting them twice. So then we would subtract. Now we could write them as individual, or you could just say 12 plus 13 minus 3 all over 52. So this is going to give us 22 over 52, simplifying that into 11 out of 26. All right, and then a queen, we have, excuse me, 4 out of 52 queens, which will be 1/13. All right, looking at 2, it says a bag contains 7 green marbles, 10 white marbles, and 4 yellow marbles. Find the probability of getting a green marble and then a yellow marble with replacement. So this is the fact that they're independent or dependent. So here we're looking at the probability of green and yellow. I'll just use the letters here. So we're using and. Yellow tells us we're going to multiply. So how many green do we have? We have 7 green out of, we have 21 marbles altogether. So I'm going to take the 7 out of 21 times the yellow, which is going to be 4 out of 21. And then they're independent of each other because we're putting the marbles back. If not, we would say we'd have 4, assuming the first one was already green, we would be down to 20, but we're replacing it, so we're still back to the 21. So here we end up getting 28 out of 441, and this actually does simplify, 4 out of 63. All right, for B, find the probability of pulling a green marble followed by a white one without replacement. So again, probability of green and white, but without replacement. We'll just first start by saying we have 7 green out of the 21 times we have 10 white, but assuming the first one was already green, that doesn't affect how many white we have, but it's going to be 10 out of 20. So here we're going to get 70 out of 420, which turns out to be 1/6. All right, for 3, just asking you to determine which events are mutually exclusive, meaning they have nothing in common, or which are not when a single card is drawn from a deck. So getting a 5 and getting a jack. There's no way to get a card that has a 5 and a jack on it, so we're going to say these are mutually exclusive. Getting a spade and getting a 10, it is very possible to get a 10 of spades, so this would be not mutually exclusive. Getting a face card and getting an ace. No, there's no ace cards that also have faces on them, so this would be mutually exclusive. And then getting a face card and getting a heart, yes, it's possible to get a jack of hearts, so we're going to say that this last one, not mutually exclusive. Again, on the final exam, I'm not looking to get too tricky or tricky at all with these problems. I just want to get a nice idea that you guys have a solid understanding of the material that we covered in its simplest type of questions. All right, so question 4. How many 4-letter code words can be made using the letters in the word pencil if repetitions are permitted, and then if they're not permitted? So the first part, I'll call this A, with repetitions are permitted. That means we have, there's 6 letters here, so we have 6 letters to choose from for the first one. Imagine like 4 blanks, and then we're just multiplying all these results. It's like the counting principle here. And then if we could still choose from all 6, we multiply by 6 each time, so we're getting 1,296. Again, this is just the fundamental counting rule. And then B, if repetitions are not permitted, that means we have 6 to choose from, but assuming we already used one, we can't repeat. And notice all the letters are different in the word pencil. Then we're down to 5, then 4, and then 3. Or we could look at this as a permutation of 6 choose 4. Going back to that formula, this is going to be 6 factorial over, so that's n factorial over n minus r. So we get 6 minus 4 factorial. Both of these turn out to be the same as 360. But a lot easier to understand it this way. If we have 4 options, we pick one letter, now we only have 5 to choose from, 4 and then 3. All right, and then number 6 is just taking us through the probability now. So this is combinations that we're going to be looking at. And of course, there are some other ways to figure this out, but I like sticking to the formula. So for a box contains 24 transistors, 4 of which are defective. If 4 are sold at random, find the following probability. So if exactly 2 are defective, that means we have 4 are defective. So we have a combination of 4 choose 2. But we're picking 4 altogether, so then that means we have a combination. If we chose 2 already, now we're down to 22. Rather, not 22, because 4 are defective, which means 20 are not defective. So from the 20 that aren't defective, we have 2 more to pick. But then we're going to take that of all total 24, and we're choosing 4 together. And then you can just use your calculator to figure out what this is. First, you might be getting 1140 over 10,626, or it might take you right to the simplified form, 190 over 1771. And you could leave it like that, or you could turn it into a decimal as well. All right, so for question B, all are defective. So this means that of the 4 that are defective, we're choosing 4. And we really don't need the other part, but this just means of the 20 that are not defective, we're not choosing any. Remember, that's always going to turn out to be a 1. And again, this will be over the combination of 24, choose 4. And then this gives us 1 over 10,626. All right, for part C, the probability that none are defective mean that all of them are coming from the parts that are not defective. So in this case, we can say we're not picking any from the defective. There should be a 4, choose 0. Times, and then from the 20, we're getting all 4 from this over the 24, choose 4. So this turns out to be, when in simplified form, 1615 over 3542. And then remember, for D, at least 1 is defective means it's the probability of 1 minus none. Let me rephrase that. It's 1 minus the probability of none. And then we have this up here. So we could actually say it's 1 minus that 1615 over 3542, which turns out to be 1927 over 3542. So sorry about the original mix-up. All right, so here are chapters 3 and 4 solutions. Let me know if you guys have any questions. Next week, I'll be giving you, we'll be working on sections 10.1 and 10.2. I'm going to give you the final exam reviews for chapters 5 through 8, which you're going to notice as soon as you hit chapter 6 and 7, and especially chapter 8, that's what we've been working on more recently. So it was mainly the focus on going back to the earlier chapters to try to remember, especially with the probabilities now. All right, so take care, guys.